Hi, my name is Ocean and today I'm going to talk about DNA as a storage. DNA, as we all know, is the root to all the information from how we look to our characteristics. DNA stores all the information about us and is present on this planet since the beginning of life. DNA is present in every living being on this planet and is as unique as a human fingerprints with millions of different traits. DNA in today's world has become a very interesting topic from biomedical field to the field of computing. We can store our data on a synthetic DNA and scientists are currently researching on the same. Unlike other storage devices that are present in today's world, DNA is the most advanced storage system. The reasons to choose DNA as a storage are: it is easily available. As mentioned earlier, DNA is present in almost every living being, and with the help of technology, we are now being able to create synthetic DNA that can store our own data. DNA, being a renewable resource, is better than silicon that is being used in optical drives in today's world, and doesn't cause any environmental effect and is completely a part of the environment itself and can be easily copied or replicated. You can create a million copies from a single DNA with same data. DNA is extremely durable source of storage as well, whereas today's storage systems such as optical drives and flash drives only can retain data stored on them for 5 to 10 years or 30 years at most. DNA can store the data for hundreds of years or even thousands of years, that too in the worst conditions. Due to its highly dense storage capacity, it is being preferred as well. As mentioned by European Biomedical Institute, also known as EBI, all the world's current data, from TV serials ever produced to movies and all other information, can be stored in just one cup of DNA. Using DNA as a storage medium, we can easily get rid of these huge data centers that occupies a huge area and also have effect to the environment. And DNA saves powers as well. DNA do not require much electricity to read or write any data onto it. As per global report, data centers consume 30% of world electricity, which is expected to be a greater number by year 2020. The main reasons of this research is because storing data on DNA or reading data back from DNA takes too much of time. Let it be converting data to DNA sequencing or writing data or DNA on synthetic DNA nucleotide. Vision of this research is to reduce the time taken in converting data into DNA sequences. Mission is to achieve this speed and make it possible with the help of GPUs, graphic processing units, that can help in reducing the time by utilizing their median cores to process the data at the same time, which can reduce certain bottleneck of converting the data. The use of GPU is also shown in this figure. Titan, the supercomputer, also uses GPUs to get performance. 90% of its performance from 27 petaflops is due to the GPUs that are used in it. Titan is composed of 18,688 Tesla K29X GPUs, which is the reason of Titan's super performance. Titan also have a LinPack performance of 17.59 petaflops. LinPack is basically a benchmarking tool to test the performance. GPU can similarly power DNA storage systems as well to make the process faster, efficient, and even error-free. Working of data conversion into DNA is pretty easy and can be done in several ways. All we need is to convert the binary or ASCII code present in the data into a DNA sequences. DNA is basically composed of 4 elements, also known as nucleotides. These are A, C, G, and T, which are abbreviated to adenine, cytosine, guanine, and thymine. DNA is based on these 4 nucleotides, whereas all the data on the computer is saved in the sequence of zeros and ones, also known as binary or ASCII code. The basic idea behind this is to convert the ASCII code, which contains only 2 digits, to convert it into quaternary format, that is the 4 nucleotides of DNA, A, C, G, and T, which can be done in a similar way in which we encrypt our data files. There are few encoders that can also do that, also known as Huffman encoder and Goldman's encoder. After encoding the data into DNA nucleotides, we can synthesize the data. Once the data is synthesized, that is written on a synthetic DNA, we can sequentiate the data again, as the DNA is composed of 2 sides and the data is written on one side at once and then on the other side. DNA sequencing joins both sides and make DNA strands that will have information about the DNA, and we can afterwards read the data back from these sequences and decode it back to the binary format that a computer can understand. How DNA as storage will work? There are only 3 steps in it: convert, encrypt, and synthesize. As I mentioned these steps earlier, let us take a deep look into how it will work. First one is to convert. As everything on a computer is stored in ASCII code, we can fetch that code and convert it into nucleotides, A, C, G, and T. In this research, we are basically going to use Goldman's encoder with little modification in it to just make it redundant, and we can also use Huffman code that will convert the ASCII code to triplet form that can reduce any chances of errors while the conversion process. Then comes the second part, encryption. Encryption is converting the triplets, also known as strits, in DNA sequences. We can use rotating encoding to avoid homopolymers, that is, creation of same type of polymers that can cause errors while writing a data on a DNA or reading data back from a DNA. As the computer can get confused, it is also shown in the figure that the triplets are converted into DNA sequences that are shifted with one space in each line. Third step is writing the DNA on a DNA strands. This process is also known as synthesizing. DNA sequences can be synthesized in many ways. One is with the help of DNA sequencer, and the other one is with the help of a 3D printer. However, the use with 3D printer is still under research, but as the company Cambridge Genomics have claimed that they have found a way to print a DNA, which means DNA sequencer and the cost can be avoided in the process of creating DNA. It is still unsure about the technology that they have used. However, in the media the report is that they are using some sort of special ink based on DNA sequences that are printed with the help of 3D printers. In short, in first step we will convert the video clip into triplet, and in second step we will encrypt or encode the triplet in the form of DNA sequences. Then third step requires the help of DNA sequencer to create a synthetic DNA in our research. This figure shows that the steps taken by EBI to store Shakespeare's sonnets on a DNA. We will be using same technique but modified algorithms to do the same with our video clip. Also, I would like to mention that EBI and Microsoft have only tried storing an audio file, text files, and an image file. All video files will take a different technique or certain encoders as well to get the binary code and get convert without any error or color loss. Next is storage limitations, which is a part of why we should think about choosing DNA as a storage option. This figure shows the comparison of hard disk, flash memory, and DNA, where it is clear that the only drawback of DNA storage is its read or write speed. Rest, data retention, power usage, and data density of the DNA is far superior than any other storage method available in today's world. So these were the benefits and methods of storing a data onto a DNA. In short, to make this possible, we are going to use GPUs and certain algorithms to convert the data into DNA sequences. And then we will send these sequences to bioinformatics lab that can create a synthetic DNA with that sequences. And with the help of any DNA testing lab, we can read the data back and get the DNA sequences. And after getting the DNA sequences, we can convert it back to binary codes from where we can recover the data. Microsoft and EBI have successfully converted files onto a DNA, which has proven that this is possible and 100% recoverable without any data loss. This research will be focused on developing an application to help converting the data and will be implemented with the help of GPUs to reduce the time taken. To check the working, we will be using labs to read the data back and also benchmarking tools to check the performance of our application. The main focus will be to convert a video clip into a DNA sequence while keeping track of the conversion speed. You can also get more information about my research from my latest blog as soon as it is up. You can check tiny.cc/ocean research. The link to my blog is also given in the description below. That's it for today. Thank you.